So today we are going to discuss examples on Z transform. Always remember the Z transform has the weightage of 15 to 20 marks. If we talk about GTU exam, in GTU exam the question number 4 and 5 is only for Z transform, so we should expect 15 to 20 marks examples as well as theory based on Z transform in question number 4 and 5 of GTU paper. So the code is 2141005 is your subject code and also your GTU exam paper code. In that, if you consider the last 5-year papers of GTU exam, the question 4 and 5 is totally for Z transform as well as Fourier transform, but we should expect the 50 to 20 marks with examples as well as theory. So let's start the basic examples on Z transform. So the question could be the question which is asked in exam, say find Z transform and comment on ROC, that is region of convergence. We will discuss in later on topics. The comment on ROC for given sequences. Say first weeks have x1 of n is 1, 2, 1, 3, and the origin or the 0th sample is at first sample. Then x2 of n, which is say 1, 1, 2, 2, and the origin at the last sample, that is the 0th sample in x2 of n, and say third sequence x3 of n, which is equal to summation 1, 2, 3, 4, 3, 2, 1, and the arrow is in middle part. So the 0th point is over here at the middle part of x3 of n. This is the 0th sample of x2 of n, and this one is the 0th sample of x1 of n. So we should find out the Z transform of x1 of n, x2 of n, x3 of n. Say x1 of z, x2 of z, and x3 of z. So for all the kinds of examples, the method is same. First step or step 1 in every solution is fixed for x1, x2 and x3. For all three examples, the step 1 is always fixed. You should write standard definition of Z transform is, therefore x of z is equal to summation n equal to minus infinity to infinity x of n over here. Step 1 for x1 of n, so x1 of z, x1 of n into z raised to minus n. Now the important point is what should be the limit of n for x1 to calculate x1 of z. So consider x1, the starting point is 0, so the 0th sample, first sample, second sample and third sample. So the last point in x1 of n is 3 or third. So the limit of n becomes starting with 0 to 3. So if we put that limit in x1 of z, the x1 of z becomes summation from n equal to 0 to 3 x1 of n z raised to minus n. Now it's very simple. The simple step to elaborate this summation by considering the value of n over here at x1 of n and z raised to minus n, starting with 0, then after 1, 2 and 3, and we just need to sum up or add it. So it is equal to x1 of 0 into z raised to minus 0 plus x2 of 0 into z raised to minus 1. Then after x1 of 2 z raised to minus 2 plus x1 of 3 z raised to minus 3. So we put x of n is equal to 0, then 1, then 2, then 3. So now put the value x1 of 0 means amplitude 1, x1 of 1 means amplitude 2, then x1 of 2 and x1 of 3, and the power of z. So this will become the x1 of z1 into z raised to 0 plus 2 into z raised to minus 1 plus 1 into z raised to minus 2 plus 3 into z raised to minus 3. You simply multiply it and the summation, the final answer becomes z raised to 0 is 1, the 1 is multiplied with 1, so it becomes 1. So plus 2 into z raised to minus 1. So you can write it z raised to minus 1, or it is the denominator part of z. So 2 by z. So it is 2 by z plus again it is 1 multiplied with z raised to minus 2 becomes z raised to minus 2. We can also write 1 upon z square plus 3 into z raised to minus 3. We can also write z upon z cube. So it is the final value or final answer of x1 of z. x1 of z is equal to 1 plus 2 upon z plus 1 upon z square plus 3 upon z cube. So this is the solution of step 1, step 2, it is step 2, the final evaluation of x1 of z by evaluating this summation ranging from 0 to 3, and then we will get 1 plus 2 by z plus 1 by z square plus 3 by z cube. It is the z transform of given sequence x1 of n. So now let us consider the x2 of n. So the step 1 is always same in all the case. It is nothing but to consider standard definition of z transform. The standard definition of z transform x2 of z is equal to summation n equal to minus infinity to infinity x2 of z, x2 of n into z raised to minus n. So the limit of now n is n limit to, or here 0 samples minus first sample minus 2 and minus 3. So the limit of n is minus 3 to 0. So minus 3 to 0, the limit is nothing but the limit of n, a limit of summation in x2 of z. So in step 2, the x2 of z becomes x2 of z is equal to summation minus 3, that is n equal to minus 3 to 0, x2 of n into z raised to minus n. So similarly as in x1 of z, if we consider x2 of z, the minus 3 to 0 summation x2 into z raised to minus n. So the summation becomes x2 of minus 3 into, now the value is negative over here, the n is also negative, z raised to minus n. So it will become the plus 3 plus x2 of minus 2 z raised to plus 2 plus x2 of minus 1 z raised to plus 1, and the last sample is x2 of 0 z raised to 0. So similarly as we put values in x1 of z, put also the values or amplitude of x2 of z. If this is for minus 3, this is for minus 2, minus 1 and 0. Do not forget, this is the value of n. This represents the location of amplitude at minus 3, minus 2, minus 1 and 0. and this 1, 1, 2, 2 represents the whole amplitude of x2 of minus 3, x2 of minus 2, x2 of minus 1, and x2 of 0. That should be always remember. Now we put x2 of minus 3. Now x2 of minus 3 is 1, so 1 into z cube plus 1 into z square plus 2 into z plus 2 into z raised to 0. So if we write in the order of z power, so the very first becomes 2 into z raised to 0, it becomes 2 plus 2z, 2 plus 2z plus z square plus z cube. So the incrementing power z raised to 0, z raised to 1, z raised to 2, z raised to 3. It is the final answer of x2 of z. So this is the simple way to solve x2 of z, x1 of z, says z transform of a given sequence, x1 of z, x2 of z. Over here, remember this sequences now we considered is finite sequences. So x1, x2 as well as x3, all the sequences are finite sequences, or we can say finite duration sequences. It means these sequences end at some finite number of values, or it never goes infinite. Those sequences will never go infinite, or it has the finite number of samples in the sequences. This sequence has 4 samples, this sequence again has 4 samples, but this sequence has 4 and 5 samples. But the total number of samples is says 7 samples. Total sample is 7. So again, this x3 of n is a finite duration sequence. So if we consider the third equation, x3 of n, before that let us see what is the difference in solution of x1 of n and x2 of n. The x1 of n is the right-sided sequence, say the zeroth sample y-axis, and they move all the samples on the right hand side. So right-handed sequence, as we discussed, the right-handed sequence is nothing but the causal sequence. So x1 of z becomes the power of z is everywhere negative. So the z power is in x1 of z is the negative power of z. So 1 upon z, 1 upon z square, 1 upon z cube. Similarly, x2 of n is with respect to y-axis, it is the left-sided sequence. So left-sided sequence, the limit of z is nothing but the positive power of z. It is the anti-causal sequence x2 of n. So for anti-causal sequence, over here x2 of z has the positive powers of z. So z raised to 0, z raised to plus 1, z raised to plus 2, z raised to plus 3. So it is the only difference that the z transform of causal sequence has the negative power of z, and the z transform of anti-causal sequence has the positive power of z. But this third case, x3 of n, is the different than all these x1 and x2, because the x3 of n has both sided sequence, because it has the samples in left side as well as right side. So 3 to 1 in left side and 3 to 1 in right side. So the zeroth sample represents the 4 amplitude, and now we will calculate the similar example. Step 1. So step 1 is standard definition of z transform of for x3 of n. So it is x3 of z. So it becomes summation n equal to minus infinity to infinity x2 3 of n z raised to minus n. So now for this equation we should consider the limit of n. So limit of n becomes, starting with 0th sample is over here, so minus 1, minus 2, minus 3, and same way plus 1, plus 2, plus 3. So the limit of n is minus 3 to plus 3. So by considering minus 3 to plus 3 limit, we will calculate x3 of z, starting with summation n equal to minus 3 to plus 3 x3 of n z raised to minus n. So now this will last for minus 3 to plus 3 limit. So let us consider all the limits x3 of minus 3 z raised to 3 plus x3 of minus 2 z square plus x3 of minus 1 z raised to 1 z plus x3 of 0 z raised to 0. Then after positive power or positive value of n, so positive value is termed as x3 of plus 1 z raised to minus 1 plus x3 of plus 2 z raised to minus 2 plus x3 of 3, that is the final sample x3 of 3 z raised to minus 3. So this will become, we consider the amplitude 1 2 3 4 3 2 1. So first amplitude is 1, so 1 z cube plus 2 z square plus 3 z plus, now x3 of 0 is 4 and z raised to 0 is 1, so it is plus 4 plus x3 of 1 z inverse is 3 z inverse, then 2 z raised to minus 2 plus z raised to minus 3. So now this is the solution of x3 of z, the Fourier transform of x3 of n sequence, both sided sequence of finite duration. This has the positive power of z as well as negative power of z. But on these three examples, x1, x2 and x3, we have not considered or we have not commented on the region of convergence ROC of these x1, x2 and x3. So in later on part, we will discuss what is the importance of region of convergence and what is the significance of ROC on Z transform of any sequence. And also we have considered the finite duration sequences. So we'll also see what will happen in the case when we consider infinite duration of sequence. So up to this we will clear the Z transform of right sided sequence. This is the right sided sequence. This is the Z transform of left sided sequence, and this one is the Z transform of both sided sequence.